Hey, what's up guys? My name is Cherno and welcome to episode 95 of Game Programming. So today we're going to take a look at continuing our chaser mob, which is open right here. And I guess what we're going to do today is actually, make him a little bit more complicated, but still building on this original aspect of him basically following our every movement. Now, what we're going to do is only make him follow us if we're at a particular distance away from him. Okay, so if we get too close, he's going to chase us. And if we get, a bit further away, he's going to stop. Okay, and this tutorial is really going to be in conjunction with the next one, because obviously right now all of our mobs move at the same speed. Okay, so in the next episode of Game Programming, episode 96, in episode 96, we're going to talk about actually making these mobs move at different speeds. So essentially what we're going to do is we're going to define a way for us to control the speed of a mob, okay? Because currently they just move at the same speed. Any mob, we can't actually set their speeds individually. So we'll talk about that in the next episode. But this episode, again, we're going to fundamentally lay down the code that this chaser requires to actually start chasing us if we get too close to him. Okay, or her, I guess. I don't know. Okay, so in if we just map out what we need here, let me just close everything. We're gonna obviously need our chaser class, and then again we're gonna need our level class because that will help us in determining who gets too close and stuff like that. So a chaser, right? Fundamentally, what the chaser does is it chases a player. Yeah, that's all it does. Chases a player. Now, what it needs to do to chase a player, again, it's only going to do that if we get too close, us being the player. So what the chaser is going to do is, if we get too close, he's going to start chasing us. So he obviously needs to know, and for all intents and purposes, chaser is going to be a he, okay? Just so I don't have to keep repeating myself, he or she, whatever. The chaser is going to have to know, right, our location. He's going to have to be like, okay, there are, let's just say, because this is a multiplayer game, or it will be anyway, there are 20 players on the map, yeah? If either one of them gets too close to me, I'm going to have to start chasing him, because that's what Cherno told me to do, okay? So we need a method, we need a way to actually figure out if one of these players is in our range, I guess. So to do that, we need to go to the level class and actually define a method that returns, I guess, an array of entities, or in this case, I guess, an array of players, in a certain radius away from an entity. So what we're going to do is, because we're not going to rewrite our code 200 times for the same thing, we're actually going to make a method called public list entity, okay? And it's going to be called get entities. Simple as that, okay? So it's going to return a list, an array list of entities. This could be an array. There's absolutely no reason to use an array. Well, there could be. There's a lot of reasons actually, but you could do this as an array if you really wanted to. I'm going to do it as an array list though, just because I like them more, and dealing with them is more fun and more flexible, of course. So get entities. So what we need to do is we need to specify an entity. That's actually going to be the entity that we get entities based on. So entity, and I'll explain this in more detail in a minute. And we also need a radius. And this radius is going to determine basically the radius is obviously going to determine the range. So what we have here, let me just quickly create an array list that says this is our result. I'm going to call it result, so we don't get confused. So this is what's going to get returned, an array list of entities. And basically what's going to happen here is we're going to cycle through all of our entities here. I is less than entities dot size. You may want to, for performance in the future, use something like quad trees or another method to only get entities that are around our location. That's a bit more advanced, and we'll only cover that if we really need to because of performance considerations. But essentially what we're going to do is, for each of these entities in size, what we're going to do is we actually have to figure out their positions. So let's first of all map down this entity that we're currently looking at. So I'll call him, he's already been taken of course by the parameter, so we'll call him entity, I guess. So entity equals entities dot get I. So this is the current entity in the list that we're looking at. So what we're going to have to determine is the x and y coordinate of this entity. So we can do that. Obviously, we made last episode in the entity class, we actually made two methods, a get x and a get y, and they return our x and y coordinates respectively of our entity. So int x equals entity dot get x and int y equals entity dot get y. Okay, and once we've done that, we now know the location of an entity, and of course we also know the location of our entity here. Now what we could do, of course, here is also make an ex, for example, which will be our e.getx, just in case you wanted to use that. It doesn't really matter, but you know, we'll do that just so we have these local variables. So ex is our entity, and x and y are just the foreign entity that we're looking at. So what we need to do now is figure out the distance, yeah? And to figure out the distance, we're gonna have to employ some really, really basic trigonometry, okay? So just some Pythagoras theorem, essentially. We just have to basically say, okay, well, we know the distance, of course, on the x axis, and we can obviously figure out the x distance by going ahead and saying, well, quickly, just so you guys know this, in case you don't. Again, probably another in-depth series topic. But for the x, we just figure out the dx, I guess, the entity, the distance on the x-axis by just saying essentially x minus ex, and that would actually give us the distance. Now the problem is, of course, if x happens to be smaller than ex, so in other words, if our foreign entity is to the left of our actual entity that we're comparing here, it'll give us a negative number, which is obviously a problem. So we can just, well, it's always going to be positive because it's the distance. So make sure that you actually put math.abs here. That will absolute the expression, actually. Well, the result of the expression, and that'll just make it positive, essentially. Make sure it's positive. That will make sure it's positive. So in other words, if that's negative, it'll make it positive, okay? Pretty simple stuff, sure you guys already know. And we'll do the same for y. So what we have here right now is the x and y distance. Now that's great, okay? That's great. But the problem is, if we use this and we just add them together, what we're going to get is we're actually going to get it's not a Euclidean distance, it's Manhattan distance. I'm pretty sure. It's been a while for me, actually, since I went over this. But if I open up trustypaint.net here, what we'll see is that this, of course, will just give us a simple, if I just get a brush here that's pretty big. If the chaser's over here, this is the chaser, and the player is over here, and we're getting the distance here. What's going to happen is, right now, if we just go ahead and say that int distance equals dx plus dy, what we're actually calculating, of course, is this distance, that plus that, yeah? And that's obviously a bit of a problem, because that is the distance, but that's only if we can't move diagonally, okay? Which we can in our game. So this is the distance that we need to calculate. So using basic trigonometry, we can work out what this hypotenuse side is, because we have the x and we have the y. So, as you know, as you should know, if you, well, I guess went to school and did maths, x squared plus y squared equals c squared, or in our case, I should write h squared. So if we rearrange this using some basic mathematical algebra, h is equal to the square root of x squared plus y squared. Okay? So now that we've got that, we have x and we have y. So all we need to do is make sure that we square them, add them together, and then figure out the square root of them. So clearly that's going to give us a decimal value of sorts. So make sure we use double, and then we can round it to an integer when required. So our distance here, our real distance, double distance, spell that properly, is actually equal to the square root, so math.square root, if we refer back to our original equation, x squared plus y squared, okay? So to figure out x squared, we can simply multiply dx by itself, and of course add y squared, dy times dy. Now, you could use math.power dx, for example, and that would give you the, I guess, the x thing, and is it, okay, make sure you square it, of course. Right, and that would give us x, the dx squared. But of course, this is just fundamentally slower than just basically multiplying it by itself, because that's just a basic multiplication operation. Whereas here you're actually calling that method. And also I think it looks nicer because there's too much math stuff going on if you have math everywhere. So that's the way that works. Okay, really, really simple. And that's it. That is our distance. So now that we've figured out the distance, what we need to do is basically say that, okay, Well, if this distance is less than or equal to our radius, then let's add it into the list of stuff to return, of entities to return. So if distance is less than or equal to our radius, then let's actually result.add our entity that we're looking at, which is entity. Okay? Simple as that. And that's it. That's literally it. That's all the code that we need to figure out if we are in range or not. Okay? Else, of course, we'll just continue the loop. It will continue by itself, obviously. And that's about it. So at the end, we just return the list of our entities, and when we're done. Okay? Now, this is a universal method that will simply get all of the entities. That's it. Now, if we want to do something like get players, we can do that as well. So public list player get players. Okay? And of course, we need the entity that we're referring it to. So in other words, the radius that we want it to use here. So in other words, because the way that we're getting these players is actually by figuring out if they're within a radius of a particular entity, which we need to specify, of course, the entity and the radius that we want to compare to. And all we need to do here is simply compile a list of players, or essentially we could compile a list of entities here. We'll need to actually. So these are our entities, and we'll just simply get entities that are within E and our radius. Okay, so we're referring back to this method that we just created. And then we'll have to loop through these things once again. Entities.size, I++, and we'll loop through these, and we'll say that if essentially entities.get I is actually an instance of a player, we'll actually add it into our new array list, which has to be an array list here of players, called players, or we'll just call it results since that's the one we're returning, equals new array list player. And of course, we'll simply result.add player, or rather result.add entities.get I. Okay? And of course, we'll need to cast this to a player, which of course that will never give us a class cast exception because we're actually checking to see if it is an instance of a player. Okay, and that's it. Let's just remove this stuff here and make it one big line because that's how I roll. And I think that's pretty much it. Okay, we'll add it. If not, we'll just keep it looking. Okay, and then of course we need to return our result, right? So that's great. Okay, let's test out these methods now. So if we go to player and we go to update here, this is in the player class, obviously not the chaser class. We can just print out here. I should really make a way to print out to the screen, because what we're doing here is we're just printing into the console, and I have to actually move my screen recorder essentially while I'm editing the video to show you guys the output. So I will probably maybe the episode after, maybe before we do the AI search algorithm, since printing stuff to the screen will be useful for that, so I can explain it better. Before we do the A-star search algorithm, I'll probably just go over making a method to print text to the screen, because we haven't covered that yet. Okay, so system.out.println. Well, first of all, we'll get all the entities around here, yeah? So we'll make a new array list called E, or ES, whatever, entities, equals level.get entities. Sorry, I actually reinstalled Windows, so I don't know why, but Eclipse isn't giving me any suggestions because I don't think I've installed a component that I should have. So what was it called? Get entities, and we level. Okay, so we need the entity that we're comparing from, which is this entity, and the radius. We'll just say 50. That's probably too far. Maybe 20. Okay. So make sure we import everything here. Next, make sure it's from util, and entities here, of course. All right, cool. So now that we've done that, we can just basically, for each of these, I is less than, we could probably just do a for each loop for this actually. So entity yes. All right. So for each of these entities, I usually don't like using for each loops because they can cause concurrency issues, but this should be absolutely fine because we're not referencing this anywhere else. But I would avoid them, honestly. And also that they don't give you the I variable that I like to play around with. If you do a for loop, if you do like a normal for loop, of course, you do get this I variable that you can use to get indexes of things and actually measure other things. That's a shame as well, but it doesn't matter. So es dot what's a good one? I guess we could just we could print the amount, yeah? In fact, we don't even need this then. We'll keep it here for now, but we'll print the size of this. And we'll also print the name. So simply E, okay? So if we launch this, so there's 0 entities around us, and suddenly there's 5. Oh, there's 5 chaser mobs. Oh, we made 5, didn't we? Oh, yeah, we did. Okay, let's go back into... Well, that proves that it works, right? If we go back into spawn level here, we can see we add 5 chaser mobs. Let's not do that. Okay, so what I'll do now is I'll kind of bring this down here so you guys can see what's going on. And you can see that over here we're getting 1, and it's just a chaser. You can see right here, and that's the memory address. Not important, but it's a chaser. Okay, and if we go closer, if we go pretty close to this one, let's see here. If we go pretty close to a dummy, and this is very close, by the way, that's why it's hard to kind of achieve. You can see we get 2 over here, and it's printing both. Let's widen this radius. It's incredibly small. I didn't think it would be that small, to be honest. If we go back into our player, and we go to the radius, let's just buff that up to about 80. I don't know, 50. I was thinking 50, but we'll see. We'll see how far that is. Okay, yeah, that's about the distance. So we got 1 over here, which is our chase. If we go close to this one, you can see we've got the dummy as well here. Go close to this dummy. Can we get both of them in there? Maybe. Yep. 2. No. Okay, we can definitely get both of these in. Yep. 3. See. And basically what we're getting here is we're actually getting the entities that are around us, and that's of course very very useful. So that's how that works. Now let's make the chaser. Let's actually do what we set out to do and make the chaser follow the player essentially. So let's get rid of all this code, and by follow the player, of course, I mean follow the player if he gets close enough. So what we'll do over here is every as we move here, yeah, instead of just getting the client player and doing this stuff, we'll basically need to get a list of entities, or actually players, of course. So players equals level dot get players, this, and a radius of around 40, I'd say. Okay, so now that we've done this, in fact I'll make it 50. Now that we've done this, all we need to do is say that if, or essentially instead of player being one of these, right? Because there's only one player right now anyway, instead of getting the client player here, we'll simply get players, right, dot get I, and that's one of these. Sorry, get I, what am I talking about? Get 0, okay? Now, of course, this isn't always true because sometimes players will be 0, this one, because of course our chaser doesn't always have to be in range of a player. So we'll simply make sure that he only follows someone if players, if players.size is actually greater than 0, okay? So if players.size is greater than 0, let's do this stuff. Okay, simple as that. So let's test that out. So he's not following us now. If we just wait here for a minute, we'll see that he's not coming, okay? And there's a bunch of these dummy mobs, but if we get close enough here, and I'll try and make sure that he's, where's our chaser? So he's red. See, he's not following us now. But if we get too close, okay, we got close, nothing happened. That was anticlimactic right there. So let's see what on earth went wrong here. So we're getting players, it's in the range of here. Let's make sure that players is actually returning something. This is the joys of programming. So let's return players at size here. So it's 0, and it's still 0. Okay, so it's not getting any players. Something must be wrong with our get players method. So this clearly works though, this entity thing. So of course, the reason this isn't working, of course, is because I'm an idiot, first of all, but also because players is obviously in a separate array list from entities, and because of that, it's not checking that. So get players shouldn't actually be in any of this. Get players should actually be the same method, but for our players. This makes things a little more complicated. I kind of forgot that. So what we need to do is, I'm honestly considering just adding players into the main array list here. That would make things much more simple. We're not going to do that though. Okay, so we don't need get entities anymore. Okay, my bad. I thought that the player was in the entities array list. It's not. So make sure that instead what we do is we actually check players.size, and we'll do the same thing here. We'll just copy and paste this code over here into right over here. Okay, and we'll get player p will be players.getI, and instead of this we'll use, we'll just write player here. Instead of entity, we will of course replace that with player here. So and instead of these guys, we'll copy and paste them again here, and write out oh yeah, that's fine. So entity, that stays as it is. We've got all that stuff down, which is good. So result.add player. All right, and we don't need this anymore, and that's it. And we'll just return result. So they're essentially the same, but they're checking different array lists. Probably not a good design, but the thing is, it's for players, and players will be, I think players will essentially be the only unique entities, of course, disregarding stuff like projectiles and particles. I may put these into one array list called effects or something, because that's what they are. Well, projectiles not really, but particles, yes. Players do deserve their own array list, though. I'm pretty sure, just because, of course, they are quite a unique entity because they're controlled by humans. Anyway, now that I've justified myself, let's see if this one works. So if we launch, we've got 0 here, and if we get close enough here, what we should see is 1, and the guy should start chasing us. Here he is, our red clown here. Here he is, and let's see if we get close enough. Does he start chasing us? Yep, okay, so there he goes. You can see this changes to 1, okay? So that's how that works. I'll demonstrate it one more time in case you guys didn't catch that. And actually, before I do that, I will stop printing. Let's go back to Chaser and stop printing players.size here. Go down all the way. Here he is, and there he goes. Start chasing us as we get close. Okay, so that is episode 95 of game programming. Next time we'll talk a look at giving entities different speeds, so that our chaser, for example, moves slower than us, so that we have a chance to outrun us. Otherwise, he will just follow us indefinitely. And then after that, we'll probably take a look at we'll take a look at making this AI a bit more complicated, but also after that, before the A-star search algorithm, we'll definitely implement text and stuff like that, text rendering to the screen, which will be relatively simple but necessary. So I hope you guys enjoyed this episode of Game Programming. If you did, please hit the like button. You know the deal: 200 likes, 1 video per day; 300 likes, 2 videos per day. And I'll see you guys next time. Goodbye.